Hello U9, welcome to another video. Today we're going to be looking at statistics in the media. Now this is a really important thing to talk about because as educated people we want to be able to assess the news and what claims people are making as to whether or not they are true or whether or not they're actually misleading. So this is why it is important to understand data so that you're not misled and that you can be properly informed about issues in the world. We're just going to go through a couple of common misleading devices or mistakes that are made in media that can cause people to think the wrong thing about things than what the truth actually is. So we're going to look firstly at the idea of cherry picking data. Now, cherry picking data is just when you have a data set that's been collected and you just take certain data points out of that data set to tell a story that might not be indicative of the whole data set. Okay, you can see here in this first graph, we've got data which seems randomly not correlated at all. You see there's blue points all around, so the variable on the x-axis and the y-axis aren't linked at all, okay? However, if you were to just take out the blue points of these circles here as the only data that you took from that data set, you would think that there would actually be a trend of going up, increasing. As you increase in the x-axis, you increase in the y-axis, okay? So if you only take certain points of data out of a data set, you can claim or make it seem like there are trends that aren't actually true of the whole data set. Okay, so this is an example of cherry picking data. Now, this is very important when it comes to certain global issues like this graph here. So here we have the global surface temperature over the last 50 years. Now, this is just one example of measuring something that shows this trend over a long period of time, that the global surface temperature has been going up over the last 50 years. Okay, now this is not the only evidence for global warming, but it can be one example of it. Now, if we only take data from a particular period of time, so we take this point from 1998 and the point at 2008, we can say, well, it was cooler in 2008 than it was in 1998. So we could claim from that limited data set that it had actually been cooling down. However, that limited data set does not actually tell the whole story of a much larger data set. So if we restrict the time frame of a particular collection of data, we can make it seem like there's a trend there when actually the trend is otherwise. So the important thing when we're displaying data is we display all collected data so that we can see the true trends. These are the important things that we need to do. And we show enough data over a relevant time scale. Okay, so we don't just pick data from a particular point to a particular point to tell a story. We've got to kind of show the whole picture there. So that's one issue of cherry picking data to make it look different than it actually is. All right, now another way that we can mislead people is in the way that we display our data. So it might be that the data is totally legitimate, we haven't cherry picked, but we've just displayed it in a way that makes it seem more significant than it might be. So here we have sales figures of a particular company over per year, and you can see it looks like that 2017 was much, much worse than the years before and after it. However, when we look in the scale on the side here, we're actually starting our scale from about 150K. Okay, so we're not even going down to zero. So this makes it look like 2018 was 20 times bigger than 2017, when actually it was not even close to half as big. Well, it's only about 50% bigger rather than 20 times bigger, okay? So we need to make sure our axes are not scaled in a way that makes certain changes look more significant than they actually are. Okay, another example of recent media shows this is COVID hospitalizations in a particular area, and it says, shows that it's going down. And now, these are true data points from this particular pace. However, again, if we look at the axes, it's starting from 40. So it looks like it's gone down much more than actually the data has. The other issue with this is it's only taking hospitalizations from 2 data points. So we're not actually seeing the whole trend. We need to make sure, if we wanted to actually know what the trend was, we would need to know the hospitalizations of all these days in between and then continuing beforehand and afterwards. And that would give us a better idea of how things were going. If we just take 2 dates, like we were talking about in cherry picking, you could make it seem like the trend was going down just by picking a particular day that was lower than usual. First of all, we need to make sure the axis is properly spread out to show that difference, to not make changes seem more significant than they actually are. Okay, now this last one is a bit of a cliche in statistics, and it talks about how correlation does not equal causation. So correlation is when you have a similar movement of data between 2 things with each other. So it looks like they're changing with each other as we go along. However, it's important that we don't immediately claim that those 2 data sets must be causing one another. Just because they seem to match does not mean that one is leading to the other happening. So here's a kind of funny example. We have number of people drowned by falling into a pool in the red graph, and then we have films Nicolas Cage appeared in. You can see here they actually match fairly well. When Nicolas Cage appears in a film, it seems that more people drown in pools. Now, obviously, this is absurd. So it's important that we don't look at a graph and immediately say, oh, because they're correlated, one must be causing the other. Okay, here's another example of it. Now, obviously, these 2 data points, data sets, there's no real explanation where you could actually claim to explain why they're linked. It just is a coincidence. Now, here's an example of ice cream sales and shark attacks. And you can see here they're very closely correlated. And you could claim that the ice cream sales are causing more shark attacks. However, there's actually another common thing that is causing this. So in summer months in the Northern Hemisphere, more people buy ice creams and also more people swim in the sea. So you can see there's an external variable which isn't shown in the graph that actually is why these 2 things are correlated. Now, I couldn't tell you why Nicolas Cage films and drownings are correlated. That's just a coincidence. Anyway, you get the idea. So here are 3 examples of common misinterpretations of data that are shown in media. So be informed, make sure that you are critically thinking about what you see, and good luck with the activity for today. Let me know if you have any issues or questions about it. Have a good day.